Ναι. Εντάξει. Okay, so welcome everybody. We're going to do this in English because we do have English speakers as well. So first of all, thank you all for coming. This is our 10-year anniversary. So our meetup has been running for 10 years, the past 10 years. So to see so many people coming in this very special moment for us is great. First of all, we would like to thank our sponsors. We couldn't do it without our sponsors, and we would really love to thank Laravel, that they have also provided us with a live speaker who's going to give us a talk afterwards as well. So thank them, big thanks for that. So the next thing is that we also have another sponsor, TypeSense. They have also provided us a speaker for this day, for this special day for us. Fanis, who's going to give us a talk later today. We also have Native PHP, who is one of the biggest sponsors we have so far. So big thanks to them as well. And last but not least, we would also like to thank our partner, Laravel Certification, which is great to have them on board as well. So we're going to do this in two parts. The first part is going to be Fanis giving us a talk about TypeSense and how to integrate it with Laravel. And then we're going to have an intermission for 10-15 minutes. And then we're going to have some behind-the-scenes speak in Laravel Cloud, for Laravel Cloud by Florian. So yeah, and I would also like to give a special thanks to all of you for being here. So a big round of applause to all of you. Thank you so much for being here. And I think we could start, right? So Fanis, whenever you're ready. Yes, of course. So this is for you. I'm gonna give this with you. First thing we're going to see is a very small video from one of our sponsors, Native PHP. So for those who don't know, Native PHP is a way to use Laravel and build applications to desktop applications and mobile as well. And they recently released a way to use Laravel, actual Laravel or Laravel or whatever you want, PHP, and then generate iOS apps or Android apps as well. So, small video to begin with. That's it. For everyone who wants to check it out, go to nativephp.com, I think, and you can see what you can build for iOS and Android using Laravel. Thank you so much. So, Fanis, without further ado, the stage is yours.
Yeah. So, hey everyone. My name is Fanis. I'm a software engineer at TypeSense, and today I'm going to be giving you a small talk about how to integrate TypeSense with Laravel Scout. Laravel Scout is a package that's built from the Laravel team to integrate your eloquent models to be able to be searched upon. So without further ado, some small things about TypeSense. TypeSense is an open source typo-tolerant search engine. It's entirely in memory, so everything is saved in RAM. It started work in 2015. It's built in C++. It's designed to be fast, snappy, and pretty much as fast as we can get it to be. We're currently serving more than 10 million searches per month on TypeSense Cloud, our managed solution that we host. We also have more than 10 million monthly downloads on Docker Hub. We have clients for JavaScript, PHP, Python, Ruby, anything that you can imagine. We also have official integrations with Laravel through Laravel Scout, our Ruby on Rails integration, and the Firestore integration that we maintain as well. So some things about me. I'm a software engineer at TypeSense, of course. I'm an open source contributor. You can check me out at GitHub. I'm currently building Kima, which is a TUI application for presentations. It's the one we're using right now, so you can check it out yourselves if you want to. And I'm also maintaining TypeSense TS. It's a client that I built for TypeScript. It's fully typed with type safety in mind. It's overly complicated, no need to get further into that. But yeah, basically Laravel Scout is a tool to get you to enable search on your already existing Laravel applications. It's pretty simple to integrate. It's using a driver-based solution, so you can create drivers yourselves. So TypeSense actually started with a third-party driver and then integrated into the main repo. So we're now officially integrated with Laravel Scout. There are currently official drivers for TypeSense, Mail Search, Algolia, MySQL, Postgres through the database driver, and there's also the local collection driver that you can use when you're locally building and developing. It's pretty easy to actually set up because you're just using a single trait on your model, the searchable trait. You're importing that, and from then on, you're basically overriding a single function, and then you can start using the search function. You can pass a query, you can get wheres, you can get where-ins, so it's basically using an ORM but searching on it instead. It's customizable, so you can customize your index name if you want to. By default, it's going to use your model's name in plural form in TypeSense. You can change that out if you want to. You can also have soft deletion support. I myself never used it, but there are, of course, cases for it. So for this actual demonstration, we first need to discuss about why should we even use a search engine on our applications. Why not Postgres, for example, full text search on Postgres? So that's a perfectly viable solution when you're starting out. So for smaller scale applications, I would myself even try to use it. But it can be slow as the dataset gets larger and larger, and you have more complex queries when you're working with those. You can start to find cracks when you're trying to introduce things like typo tolerance, synonyms, curation rules, faceting grouping, presets, even vector search. So there are a couple of features that are a bit hard to get into when using a SQL-based solution. TypeSense is basically a little box that covers all of those features and more. So you can basically use it on your existing application to be able to search as you type and have the results come in basically real time. So apart from using a search engine, why use TypeSense specifically? So TypeSense, as I previously mentioned, is fully open source, so you can self-host it if you prefer to do so. You can either use our managed service that we build the infra for you and give you a dashboard as well if you want to use a UI instead of just integrating with the API. It's super fast, so because everything is saved in RAM, we're trying to be under 50 milliseconds in large datasets. We actually have a demo that's using 32 million different songs, and most of the queries are under 10 milliseconds in that sense. We have a standardized RESTful API, and it's consistent across all of our client libraries. So even if you were to migrate away from PHP, for example, and want to use the JavaScript client, the API will be exactly the same. It's AI ready. In the world of AI right now, we support things like vector search, semantic search, where you search for things that are conceptually similar as opposed to a pure keyword match. Like, for example, searching Beethoven, getting results like symphony or music composition in that sense. We also support natural language queries where you would search, for example, I want to find something like, I want to find an SUV that's made by BMW. By default, a normal search engine wouldn't get you those results, but you can use AI to basically get TypeSense to create those queries for you and for your users. And you can also use conversational search or what's most commonly called RAG to basically provide chat-like experiences where instead of having the results in a structured format like JSON, you instead get a response from an LLM, so it's human readable, and it's basically like interacting with ChatGPT. Also, it's pretty well documented. We're trying to document every single feature with examples and many demos in many different languages, many different frameworks. So we have demos for Laravel Scout, but we also have demos with Next.js, for example, with Vue, with everything that you can probably imagine. On this demo that we have built, we're trying to integrate TypeSense with Laravel Scout. We're using a simple game model that we have gotten from Kaggle. It's a public data set. The model itself has a name, that's the game's title, a release date of when the game released, a price in a float format in US dollars. We have the number of positive reviews for that game in Steam. We have the number of negative reviews for that game in Steam. We have the app ID that Steam uses to insert all of its documents, and you can use it on your URL to find those in Steam specifically. We have the approximated minimum number of owners that have bought the game in the past, and the approximated maximum number of owners, because we don't have context on that. And we also have the hours, the average hours needed to complete the game in single player from how long to beat, which is a site that aggregates how long users took to actually use that, to beat that game. So the basic model itself in Laravel is pretty bare bones. You can see that I have casted some things here. I have a table name. I'm using just the factory. But we can simply just add the searchable trait. We import it, and then we implement it inside our model. From that point on, we basically need to override a single function. We basically say what the searchable traits of this model are. Sorry. Here I'm basically just casting string to app ID and ID because I want to search by those, because only string fields are searchable in TypeSense. And I'm getting the timestamp of the release date of the game because in TypeSense we do not support datetime formats. We instead use Unix timestamps to compare on those. So this is basically the general gist, and now maybe we're going to see how it looks in action. Let me pull up this demo over here. So actually, let me go to the, it's the Scout PHP file. Yeah, so this is the scout.php file. Here you configure Scout for your application. By default, the driver is set to be Algolia, but you can, of course, override that. We've overridden it to TypeSense. You can give it a prefix to save all of the indexes to. You can use a queue driver, so it supports queuing as well. Any sort of queue driver that Laravel typically supports, it's included over here. You can use, you can also do things after committing and after database transactions, so you can run callbacks on those. And here we have different, other different parameters, but the main gist for TypeSense specifically is over here we basically instantiate our client over here. We give it the configuration it needs to actually run, and then we have model-specific settings. So we import the game class over here. We give the collection schema, so we know that we want to have a name that's going to be a type of string, the price, the HLTB single, LTB single field, the positive number of reviews, the negative number of reviews. So we are essentially doing nothing else from the general table, but we have also included an embedding field to basically generate embeddings in TypeSense to use semantic search for. It's pretty easy to implement. As you can see, you just say that I'm going to embed from a certain field. We give the name of that field, and then we provide the model config. This specific one is open source, and it's available on our Hugging Face repo, but you can use OpenAI, for example, or Google's Palm API to do things like that. And yeah, that's basically it. We provide the default sorting field and the search parameters. The default search parameters, we can override those, but if we don't want to pass the query parameters every time that we're searching, we can do those things over here. So jumping onto the actual demo itself, I see that we do not, okay. So basically, I've built this using Inertia.js, and under the hood it's running with, Vite and React, and we're using Instant Search, which is a library developed by Algolia for search-enabled applications. We maintain a simple adapter for it, so you will essentially pass the adapter object when you're instantiating the Instant Search component. And here we can use TypeSense to basically query by anything that we like. So we have 10 years worth of games here to search against. So for example, if I were to search for Metal Gear, you can see that now I'm getting results as soon as I type things out. I'm by default sorting by the relevance, that the relevance here equates to the default sorting field. But if I were to sort by the positive number of reviews, you can see that I'm getting the Metal Gear Solid 5, first of all, because it's the most popular one and has the most reviews. You can see that TypeSense is not just confined to basically searching. We can use any sort of filters. Like here I am applying a price filter that I can use this slider to apply filters in real time, and results are basically coming in milliseconds. I can add additional facets over here, sorry for that. And I can tinker with the results per page, and as I start to show more results, it's basically instant, and I'm having a redirect over there. And yeah, would you guys want to maybe tell me a query to search for to see how TypeSense would behave, or if you have any questions on up to this point specific to TypeSense, maybe we can check those out. Yeah. Yeah.
So is there a limitation on the object size? Because for
Yeah.
Algolia, there is some limitation.
Yeah, I mean, I think it's most probably huge in Algolia as well, but there's no hard cap on how large a document can get. But as you start introducing more and more fields and for example, if you have array fields and you have thousands of values in those, searching is going to get a little bit boggled down. So most often than not, there are optimizations for that. For example, if you were to have an allow list, I've seen it come a lot of times. Instead of using just the array and filtering by that array, you could use the joins feature, which is essentially using a join in SQL. You could do that. But there's no hard cap, but we would advise not having like tens of kilobytes worth of data in a single document itself.
Okay, and what about security? Is it possible to restrict access from guests?
Yeah, so by default, TypeSense uses API keys to authenticate and provide users access to different actions, but you can also use what's called the scoped API key, where you embed filters or any sort of search parameters that cannot be overridden by a user. So if you were to have a multi-tenancy app and you wouldn't want some users to have access on some sort of data, you could just create a single API key, use that on the front end, and then users wouldn't actually get to find anything that they shouldn't have.
Okay, is it possible in some way to have the API key in the front end and not having the front end, not having the TypeSense API accessible from the guests?
The TypeSense API key, so we most often than not advise to actually use TypeSense directly on the front end, because you would create a single API key that only has access to searching documents as opposed to doing anything else. But you can relay it to the backend and not use TypeSense on the front end, but relay your queries over to the backend if you're that conservative about using TypeSense directly on the front end. But yeah. Any other questions? Yeah.
What about the performance in RAM in the server? Using large datasets to make sense.
So because we save everything in RAM, there's typically things that are not meant to be searched upon. Like, for example, if I were to have a URL field for displaying the image for the game, for example, you can set those as unindexed fields, and you're going to just save them on disk. And when we get the result, we just fetch it over to the front end and display it accordingly in the API response. But other than that, TypeSense is not meant to handle like terabytes worth of data. We're catering towards site and app search, so we're similar in sense with how Search and Algolia might do things. We're not like Elasticsearch in that sense, where you can have observability and having loads of data be searched upon with caching in disk and things like that. We just save everything in RAM to be as fast as possible.
So is it actually possible to make searching live data?
In terms of by live data, you mean when I'm actually updating the dataset, it being updating in real time? So yeah, to answer that question specifically, that's actually entirely possible with Laravel Scout without needing to change anything. So if I were to pull up, let me pull up the REPL. So I'm going to open up Tinker. So I actually have an example that I was trying to, examples, sorry. I cannot see up to that point. So if we were to create, for example, a game that's called TypeSense is Awesome, and we use a REPL to create it, let me pull this up. Now, if I were to refresh my page over here, you can see that if I remove every sort of positive review or else, let me pull this up. So I'm searching by nothing. So I'm sorting by, by positive review, that's why. So if I search by relevance, you can see that TypeSense is Awesome. Essentially, when we get the document, when you index the document in the database itself, we're indexing it in lifetime. So there are some limitations to this. For example, if you were to have multiple indexes per second, like let's say more than 5 or 6, then you should do a batching. You could do a batching algorithm to basically use our import API, which the import accepts many different documents, so we can import millions of documents. This actual demo was built using that import. But other than that, if you're less than 5 or 6, you do not need to use any sort of batch importing or keeping any sort of buffer tables in that sense. But we're actually introducing buffered writes into TypeSense right now. So by the time we're talking about this, there may be already a PR in TypeSense that enables that. But with Laravel Scout specifically, every index that you're going to have on your database itself, it's going to be reflected in real time on TypeSense as well. Any other questions? Yeah.
How easy it is to change field type? Let's say I store the ID as an integer, and then I want to make it a string to make it searchable.
So there's actually 2 ways to go about this. If it was like, let's say, just a single field, you can use our update function API route that actually lets you update fields on a specific collection, but it gets limiting in the sense that you cannot change the default sorting field, for example, if you were to want to do that. For that, there's actually a mechanism that we use internally in our integration that's called the aliases feature, where instead of doing that, we would create a new collection, index all of the data into that, create an alias, which an alias basically lets you query by any sort of name and point it to a specific collection. It's basically a symlink. And then you will query by that, and it's ready to go. We use it often specifically in, there's a dog scraper that we use that we actually do that there by default. Yeah.
On the semantic search, we haven't seen it yet.
So, yeah.
But, no,
Yeah, we could, but yeah, keep going.
no, I was just wondering, like, you specified the model,
Yeah.
right? And TypeSense just
So what?
locally.
Yeah, so that will be indexed in memory as well. So we find the model. There are, I think, 12 or so models that you can use. Most of them, one of them, for example, is SentenceBird, which is built on Wikipedia data. So it depends on the actual use case. But from that point on, when you actually index something into TypeSense, we will generate the embeddings and the indexing time. So it will take a hit on performance of indexing, of course, because we have to generate so many embeddings, as you might know about. But yeah, after that, when we're actually searching for something, like let's suppose we search for Beethoven here, which is Beethoven. So you can see that we're getting results for Mozart, Ludwig, Frederick, Resurrection of Music, Color Symphony. So things that are conceptually similar to Beethoven itself, but not Beethoven in that sense. This is called hybrid search because we're actually using it in conjunction with regular keyword search. You can opt to do whichever one you prefer. We actually generate embeddings as users start to type in as well. So every time we type a new character, we are generating the embeddings for that search query. But yeah.
One more question
Yeah.
for me, like the relevance scoring.
Yeah.
Is it similar to Elasticsearch?
You can tinker in terms of actually, so Elasticsearch has so many different parameters that you do not know about the default one, but you can tinker with it whichever way you prefer. There's actually ways to actually boost results based on filter queries. So let's say I want to boost up results that are the most well-reviewed, regardless of what the user types in. We can embed basically a filter in our sort by clause. It's called an eval clause. You will see it come up in the documentation if you go through it. And you can boost results up to that. You can also apply weights to them. So if I were to have multiple filters and I want, for example, brand of Nike having more precedence over brand of Adidas, we can do that as well. But there's all sorts of ranking and tinkering with that. TypeSense can go really, really deep into curation and ranking. Yeah. Any other questions? Yeah.
The thing that you just did, that you search the token and we get module,
Yeah.
for example, is it possible to get parameterized locally for your data set?
So yeah, you can actually run, so you can import embeddings manually in TypeSense as well. So if you were to have a model being run specifically in your dataset that you have built, you can just import the floats. It's just floating point numbers in the end of the day. We're just doing a k-near neighbor search, so it's not that complicated. Or you can use OpenAI, for example, if you want to do something with OpenAI, but you basically have to pay OpenAI to generate those embeddings. Yeah.
Can you explain, please, how the joining works? Because in our database, we have a lot of models,
Yeah.
and they're deeply coupled. And for example, we have books, we have sellers. Each seller has a different payment method. So
Yeah.
how do we filter a book based on the payment method of the seller?
Yeah, so there's one main thing with joins in TypeSense. We currently do not support querying by joint fields. So if you were to want to join by those joint fields, you can basically create, so previously in the scout.php file, let me pull this up, scout. You can see this after, what was it called, after index? After commit. So you can instead run a callback here to have to basically have nested objects inside of objects. So because it's JSON in the end of the day, you can do that if you want to search by those. Other than that, you can just mention that there's a reference to another model, to another collection, but you have to do it in TypeSense itself. So it's not available in Scout by just mentioning a reference, but you can do so in TypeSense, and then you can filter by all of those out. It takes a hit on performance in the sense that we're doing things on runtime instead of indexing time. But yeah, it's entirely possible. Any other questions? Yeah. Yeah. So yeah, basically conversation search is us getting the results using embeddings and using vector search. And then when we get those results, we pass them over to the LLM of your choice, pass them the system prompt that you have built. We don't do this on every call, of course, but the initial call does that. I actually have built a demo that actually uses this, so maybe I can pull this up. It's PG, so I cannot see it that far. So yeah, let me scale it up. So this one is actually built with Paul Graham's essays. It uses TypeSense to query the results, pass them over to an instance of GPT 3.5 Turbo, if I'm not mistaken. I may have forgotten which model we were using exactly. And when we get those results, we use the LLM to create the response in a human-readable way. So if I were to ask it what the maker schedule is, you can see that TypeSense will get the results and then pass it like an LLM would. You can see the sources afterwards because we do know what matched actually before passing it to the LLM. And it keeps context of previous conversations because we actually save things in TypeSense as well. So even if I were to ask it, tell me more about startups, it will know about what I asked it before, and it will now get me more personalized results in that sense. But yeah, this is basically conversational search in a nutshell. You can use it for either directly, or you can use it as a helper of sorts in a help widget if you want to go that route, because it has context on your dataset itself. So it would be, I was actually thinking about introducing this into our documentation search itself, but yeah. Anything else? Then I suppose we're kind of finished. If you guys want to go deeper into Laravel Scout, we could, so showcase how it works under the hood. But yeah, it's basically, that's basically my talk for here. Yeah.
Thank you, thanks very much. Great talk. You can give me this, yes?
Yeah, yeah. Let me.
So guys, we're gonna have a 10-minute break and we'll be back soon. Thank you so much. You can grab something to drink and be right back.
Should I put it on already, or?
Okay. Perfect. So thanks, Fanis, for the first talk today. Next, we're going to have Florian. He flew all the way from Austria. He's in the Laravel team. He's an infrastructure engineer. He's going to talk about Laravel Cloud and some best techniques. So, Florian, the stage is yours.
We're starting with the sponsor video, right?
This is a small video from one of our partners. It's called Laravel Certificate. And we are very, very happy to have them on board. You can visit our website and see anything you want about certificate. We're going to have a giveaway at some point, probably in October, in our next event. They are very happy to share with us a couple of licenses for Laravel certification. So if you're interested, just let us know and we'll figure something out. Go ahead, Florian.
Congratulations, congratulations, 10th anniversary.
Πατώντας το ματάκι. Δεν κλείνει το ήχο του web. Πρέπει να αφαιρέσω.
Hi Laravel Greece, congratulations on your 10-year anniversary. Hey people from Greece, this is Robert, chairperson for the Dutch Laravel Foundation and also a proud member of the advisory board of Laravel Certified. Congratulations with your big anniversary. Keep on doing awesome stuff and I hope to see you somewhere in the future.
Singhariteria, Laravel Greece community, congratulations on your 10th anniversary from everyone involved at Certification for Laravel. A heartfelt congratulations and we hope you will be around for another 10 years. Enjoy your day.
All right. Where's my presentation? Here we go. Okay. Thank you very much for inviting me to come here and speak. My name is Florian. I've been working with Laravel in the cloud infrastructure team for just over a year now. As already said, I'm from Vienna, Austria. What we're gonna do today is, first I'm gonna give you a small overview over what cloud can do. And then we're going to talk about how cloud does it, so the infrastructure behind how it actually runs your application. I'm sure we're going to have space for questions afterwards, but I want this to be a very interactive session. So whenever you've got a question, please just ask. I think there's a mic going around somewhere. I'll be happy to answer your questions during the presentation. That's all my slides. Let's go into the demo. Yeah, but that just says demo. So I thought we can skip that because, you know. All right. Let's go to the cloud website and to my terminal. Great. So what we're first going to do is just create a new Laravel application and deploy it to cloud, just to see how easy it all is. So we're doing Laravel new, let's call it Greece. Yeah, I don't really care. Whatever. Pest, of course. So I'm just creating a new empty, so to speak, Laravel application. What I gotta do is upload it to GitHub, because at the moment we're supporting GitHub, GitLab, and Bitbucket. There's probably gonna be some more specific ones like your own hosted GitLab and that sort of stuff in the future, but those are the three that we support right now. Yep, run it. All right, so we have a new Laravel application here. Let's git init that and add everything. And then I guess we'll just commit it with a first message, right? And then we gotta add the remote. Yeah, I'm sorry. Wait, let me go. Yeah, I, I can do this. Maybe that's better. All right. So we need the remote GitHub under my account, and I think I called it Greece. See, nope. Okay, what did I call it? I'm sorry. Pretty sure I created it this morning. Yeah, I did. Why is it not here? Probably a typo. Yeah, we'll do the copy paste one. Get rid of that. There we go. Okay, sorry for that, but we should have a repository here now. So yeah, what we can do is add a new application. Gotta make sure I have the permission to access that. There we go. Right, let's deploy it in Frankfurt because it's the nearest. And that's basically it. So when you're creating an application, all we need from you is your source code. So you create your application, you develop it locally, and once you're ready, you just connect your repo and hit deploy. And the goal is, I hope it works now in that time, but the goal is a sub 1 minute deploy time from connecting your repo to us giving you basically a URL where you can find your new application on the internet. Of course, you can connect your own domains to it and so forth, but you'll always have a Laravel or cloud domain where you can access your stuff that you deployed. So let's see, 30 seconds for build. See if we can keep this up 1 minute, I'm not sure. Sometimes the build service is just too busy. There we go. Yeah, so now we're ready. Now we have this visit button here, and if I click on that, it took me to this window. I don't know why. Here, yeah, that's our application that we just deployed. So you see, it's really easy, and cloud sort of takes care of everything that you need. And if you look up here, it's got maybe a bit small, but you basically got the name of your application, the main of your environment, a random string, and .laravel.cloud. So that's your default domain that you get randomized. You can edit that and, I don't know, make florianbeer.laravel.cloud if it's not used somewhere else, whatever your application is called. But this one you get for free just with the deployment. Right. Yes. So what we have here now is called an environment of an application, and I can create new environments. So I could select another branch, for instance, here, or I could select the same one and create I don't know, a new environment to test out PHP 8.5, you know, when it comes out. So you can have your code running there and you get a new URL, everything. You can connect it to the same database if you want to, or cache, but you probably don't want to. So you can create a new one, connect that one, but you're completely free. You can create as many environments as you want. You can, so for instance, what we most of the time have is like a dev, staging, and production environment, where maybe dev and staging are a little bit smaller. you don't have that many CPU and RAM, but the production environment, for instance, has huge 4 gig instances that can auto-scale to 10 if there's a lot of traffic and that sort of stuff. So that's all separated by environment, but it's all under one application organization here.
If you want to create automatically, let's say you create one brand.
Yes.
Automatically.
Already been worked on.
Okay.
So what you can do now is you can clone environments. So if you have everything set up, including like environment variables and stuff, you can replicate it. You can, I think it's a relatively recent feature. Yeah, you can replicate it here. So that's already working, but that's a manual step. Yeah, of course, what you're saying is like preview environments for PRs and stuff. But it's in the works. But yeah, this already works. So you can specify, hey, take my database with you and take my cache with you, but you know, name it staging, and then you've got like a copy of your main environment and can use it for something else. He was first, I think. Yeah, go ahead.
Can you do things like Jenkins, for example, before deployment, to have commands to run, maybe some third-party servers to run before deployment?
I mean,
Maybe integrate.
I would do that in my CI/CD in GitHub, to be honest. You know, because what we do have is, so if you go to settings here, and I think it was, yeah, under deployment. So push to deploy is always selected. So whenever I push to main, it'll push that code up, it create an image and deploy it. You can also activate a deploy hook. So if, for instance, I don't want push to deploy, but I want a deploy hook, I can copy this one and put it into my CI/CD and say, okay, whenever all my tests or whatever pre-stages I need to run through are done and we're successful, then ping this URL. You can also ping it with a specific Git hash or I think even a branch, and then it'll deploy whatever you tell it to as a response to the webhook call, so to speak.
Yes, as I can see, you already have a command palette there that you can add anything you want.
Yes, so you do have, and I'm gonna speak to that later when we go into the infrastructure part, but you do have build and deploy commands, and there's a specific reason why they are split up in two, but yes, you can. So for instance, your whole migration would run in the deploy command immediately before your application receives traffic, because that's where you need to set up, you know, new tables or new fields that you added. But you can do whatever you want there. You could, in theory, download a binary from the internet, install it into your file system and have it available, but sort of, yeah, not a use case we really built for, but it should work, you know. Yeah, please.
Do you have access to CLI, right, from the web?
No. What you do have, let's jump ahead to that. You do have this command feature here. So you can run, you know, one-off commands and they'll be executed in your running application. What you don't have is interactive, like on a shell, like SSHing into the application. And no, there's, and the thing is, it doesn't really make sense in the architecture, because your application runs in a container and there might be multiple of that's running, right? So which one do you connect to? What's the expectation there? Because it's not the same model as a virtual server or a physical server where your application lives. Here it's more of a ephemeral container that might even, you know, get torn down seconds later and another one is started and that's serving your traffic now. So there's no real use case. We are working on ideas and ways to maybe add that in the future, but for right now you can run one-off commands and you'll get the response back immediately, but you can't do Tinker or connect Tinkerwell to it and that sort of stuff. So that's not. Yes. Yeah. gonna do reverb. It's not yet in the interface. We really want to have it as like a one-click addition to your application, but yeah, also coming soon. Right, so maybe let's go through what the infrastructure actually looks like. So we're building the whole platform on Kubernetes. Kubernetes, for those that don't know, is a container orchestrator, meaning you give the API, the Kubernetes APIs, a set of instructions and say, hey, please run those containers for me, and then the API will take care of always running them, always having them in the right configuration, routing traffic to them, having multiple replicas running with load balance traffic, that sort of stuff. And if we want to go left to right, so we needed a place where our traffic can get into the network. And pretty early on, we decided on Cloudflare as our sort of World Wide Web input point, wherever Cloudflare has a point of presence, which is in every country in this world by now, I think, you're entering the Cloudflare network. And what we did then is register each of our applications at Cloudflare, and they support metadata. That's basically a small set of JSON parameters that you store with your domain or host name. And we tell it, this hostname actually lives on this Kubernetes cluster that's running in one of our regions. So currently we've got Ohio, Frankfurt, London, and Singapore. More to come pretty soon. And we sort of tell Cloudflare, hey, that actually lives in this cluster, and then it routes the traffic there. Each cluster has an ingress controller that's sort of like a reverse proxy you'd have on a normal server that takes the traffic and says, okay, I know exactly where this container is running, where this traffic should go, and routes it internally to one of dozens up to a few hundred nodes in a cluster. And each node is like a server. A cluster is just a conglomerate of servers that can, coordinate itself together. And we're in a fully dynamic system here. So our clusters shrink and grow depending on how much workload is actually running there. So if people are deploying lots of stuff and they happen to all be on the same cluster, then AWS for us will automatically add additional nodes until we have enough resources to run everything that should be running. Also, if a customer gets a massive influx of traffic and needs to run multiple replicas of their application, and we don't have enough nodes, then we'll automatically add nodes, which is a relatively fast process. And then there'll be much more space in the cluster to run all those replicas and deal with the additional traffic. Then if we go down to domains, I already showed you we've got Laravel Cloud randomized domains that you can also edit if you want to say it's something else. You can add custom domains to it, which we will also register at Cloudflare. So they basically work the same as our cloud domains. They're just your own that you have to buy, and they don't have to be bought at Cloudflare. You can bring it from any DNS registrar that you want. Right, so, and then Cloudflare decides where the traffic goes. The traffic goes, in this case, to Frankfurt, EU Central AWS region. And what you can decide here is, how does your app actually react, I'm here on a relatively small Flex instance. We've got Pro instances that have more reserved resources. Flex is more of a shared model where each customer or each application will have spikes in traffic and resource usage and others not. And it's sort of, it balances each other out. But if you take Pro, then you've got these reserved resources. And what you can do with autoscaling is that at the moment, we support CPU and RAM autoscaling. So if your application uses more than, I think it was like 60 or 70% of its CPU or RAM, it can scale up. And I can decide how many. I can say, I want 4 replicas, but I always want 2 replicas running. So scale down to a minimum of 2 and a maximum of 4. And that way I can really easily control the costs, because 4 will of course cost a lot, but that might only happen each afternoon for like an hour. And the rest of the time I'm fine with running 2 instances, and it'll load balance the traffic between them, and and my application runs smoothly. What I can also do, if I don't want 2 instances running all the time, I could enable hibernation, which completely removes your application code from our clusters. So we stop the pod in Kubernetes. There's nothing running. You don't pay anything. The only thing you incur is like the startup time. So when the first request comes back to your hibernating application, it'll take between 8 and 12 seconds until the container is actually running again. And your first request will just hang and then show your application once it's up and running. While it's running, you can receive normal requests, and then you've got this timeout hibernate after, where you can say, okay, after a minute, 5 minutes, 60 minutes, whatever. For instance, your staging environment, while your developers are in the office, set it to 20 minutes. So when they go home in the evening, 20 minutes after everybody's left the office, your whole environment will shut down, you won't pay a thing. And the first one in the morning can wake it up by just, calling a URL in the web browser. So now, we of course have a few Laravel specific integrations here as well. You can run the scheduler by just activating it here. No need to set up a cron job. 1 second. We do support Octane, which uses FrankenPHP under the hood. So there's no PHP FPM. It's a PHP application server that you can use. And it's a long-running process, so it doesn't create the whole world on each request, but it has an in-memory version of your app running, so don't produce any memory leaks. Right.
So it's fairly common in traditional VMs to have, from time to time, an exposed VMP file or whatever. Do those requests wake up the instance?
Yes, each web request will wake it up. Of course, we do try to mitigate that on the edge at Cloudflare already. So we're using a lot of their bot protection and denial of service protection, that sort of stuff. But yeah, of course, you can never be sure. If you've got a friend who wants to have you pay more money, they can just, get on their phone and call your website every 10 minutes. There's not really much you can do against that. You can stop your application if you want to. If you want to keep all the settings, you can hard stop it, so not hibernate it, but really, just like stop it on the whole platform, and then you have to press a button to start it up again in the Cloud Web Interface, and then you can access it again.
Is there zero cost when it's stopped?
For the application itself, yes. If you've got like a cache or a database that doesn't hibernate connected, those will still incur costs because it's infrastructure that's running for you. But when you stop your application or when it hibernates, it doesn't run anywhere. Your code doesn't exist on our platform. It just exists in the web application, so to speak. So there's no cost for you.
And is there a way to schedule that?
Say, for example, I want my app to run 9 to 5, Monday to Friday, and then...
Good idea. No, not yet. When we have our API, which is very soon, I hear from the web application team, I hope. Yeah, then it would be easy, I guess. You can set up a cron job. Right, last point, inertia SSR. I don't know if you're using inertia. Inertia is basically TypeScript together with Laravel. And SSR is basically the server-side rendered process, so you don't have to set that up either. You can just activate it, do a redeployment, and you'll have properly server-side rendered inertia pages. Of course, you can add background processes like long-running stuff, like queue workers, for instance. What I would suggest instead of running them in your web process is adding more workers. Like I can say, hey, I've got a really big queue job that needs a ton of resources, and maybe should even scale, and then add, yep, that's fine. Add this background process, go away, and save and deploy. And then you can see, oh wait, let's go back to this screen actually. Then you can see you have an additional an additional worker cluster. It's called cluster here. It's basically another set of pods that's running in Kubernetes that's not receiving web traffic at all, but that's running your code base where you can have typically worker, queue workers, or any other long-running process that you want. So if you look at the commands, what I showed you before, you can do sort of one-off commands, but if you got something like an artisan command or whatever that you want to have like running like a daemon in the background, you can use this and add as many as you want. I mean, we've got customers that have one worker cluster per queue worker and have like 50 queue workers, so they've got a long list, but it works. It's sort of every worker is another copy of your code in a container, but it won't receive any web traffic. It just has the connection to database and cache and whatever you set up. On that topic, we do have databases. Postgres or MySQL. Postgres is run by Neon, so a third-party provider. They just integrate really well with Laravel Cloud. They have the advantage that they can hibernate as well, so that can be pretty cost efficient. Laravel is run, Laravel MySQL 8 is run by us, so we have specific clusters that only run databases for us. Tens of thousands by now. It's a bit scary being a big database company suddenly. But yeah, they don't autoscale and hibernate yet. Might add that in the future. But you can run your typical MySQL stuff that you had before. In my opinion, if you don't need something specific from MySQL, use Postgres, because you're using Eloquent anyway. It's gonna translate all the SQL for you. You don't have to really be specific about what the database layer actually is, and it's working great. All right, now maybe a bit of how the whole thing works in the background once I press this deploy button here. Let's take a closer look.
Can I make a question?
Yes.
Regarding the sessions, if you have one infrastructure, one server that is going to happen, where do you keep the sessions?
Well, it depends on your session driver.
File system?
You have a file system, but it's ephemeral, meaning if Kubernetes decides that, hey, I don't need this node anymore and your pod lives on that node, it'll shift it to another one, restart it there, then all your file system changes are gone because it's a container, you know. So if you want to persist stuff, use a database, use a Redis cache, use S3 as file storage. Treat the local disk only as a temporary storage for, I don't know, uploaded files that need to be processed in one request. But in cloud, like the cloud native approach is treating every request as an encapsulated thing. You know, it's not the same as Vapor, where Lambda really starts like the application new for every request. So it can be a long-running container, but in Kubernetes, it could be at any time that it decides it needs the resources shifted elsewhere, and it'll start a new container and destroy the one that was running, and then you've got basically a new server again, you know.
So something else? What's the provider? As you mentioned, is AWS.
Yeah. For the moment, yes. There are thoughts about some multi-cloud. At the moment, we're using so much of AWS stuff, and we know that they're in each region that we might possibly want to go to, and are a pretty big player. So yeah, that's what we pursued for now. We've got a pretty good contract with them for the future. I'm not sure. We have some concepts of how we could move it to different clouds, but at the moment I don't really see the need for it. Might come up in the future. It's a very young product. We only launched in February, so yeah, I don't know yet.
Thank you.
Right. So what are we seeing here? I told you before, we have those two parts. We have build commands and we have deploy commands. And those are the two steps that are running. So the first one that's running, if I press deploy here, is that our build cluster actually just gets a UUID on a queue. That's an SQS queue in AWS. And our build cluster has a Go program running on there. So it's not PHP. It's actually different programming language at the cluster level. And we're getting that UUID and then talking to the Laravel API of cloudlaravel.com and asking it, hey, what do you want me to build? And it gives us the repo link and so we can get the source code. And then we have a sort of base image that we decided on what are PHP extensions that people want, what are additional binaries or changes in the system that they might want. And everybody gets the same image. We just plonk your Git repo on top, so to speak. And that's also where the build commands run. So all of your composer install, all of your front end stuff. I mean, you've seen these logs thousands of times. It's just the same as if you're building it locally. Just this step runs in our build environment. And as the last step in the build environment, it'll take your, wait, let's go up a bit. It'll take your, the image it created and it uploads it to an ECR, an Elastic Container Registry. It's like Docker registry, but in AWS with only specific accounts being able to access it. And then it communicates back to this web page and says, hey, these steps are done. These are the logs for it so we can display it. And then it goes to the deployment. And we built the whole system up in sort of a way that the whole source of truth is the web app DB in the background. So the clusters themselves that run customer workloads know very little about what's actually happening. They only have an operator running, which is not a Go program, that continuously talks to the web app and says, hey, is there anything that should be running here on my cluster that isn't? Or anything running that shouldn't be anymore? And then it sort of evens it out with what should be happening and what's actually happening in the real world. And that's all it does. So we actually made the test before launching. We deleted a complete cluster, like 25 nodes, just deleted it in AWS, and then started it up again. And it basically worked. It talked to the web app and said, hey, these are the 300 apps that should be running here, downloaded all the images, started up the application. So we're pretty resilient as long as we don't lose our single source of truth, which is highly secured. So I don't think that's going to happen. So yeah, the final step is the actual deployment. And the web application even decides which cluster your deployment goes to. So you decide which region, and the web app knows, okay, I've got like 25 clusters in this region, and cluster number 23 has the least applications, so I'm going to deploy you there. And then it just sends another UUID to the operator running on that cluster, and the operator says, okay, that's a new deployment, I don't know about that, please tell me everything about it, talks to the API again of our cloud application, and gets all the information about how many replicas and what version is running, what's the host name, all that sort of stuff. And then it basically creates your application until here at the end, it then sees, well, in this instance, there was already a version running, so it made sure that the new version is up and running and healthy and can receive traffic. Then it shifted over the traffic to the new version and destroyed the old one, so you don't need two replicas running if you only want traffic on one of them. So you've got zero downtime built in by design by Kubernetes. There's no other way to do it. It's not an actual add-on or anything. It's just the way that Kubernetes does stuff. And I think that's pretty neat because it's a production environment from the get-go. Even your dev environment will just always be online once you deploy it here. Right. I'm gonna skip a few steps. I'm around afterwards. If you want to go deeper into any of those topics, there's plenty of more to say. I just think we don't have like 3 hours here. Another interesting tidbit, maybe we're running pretty modern setups. All of our clusters that run your actual workloads, they're IPv6 only and run on ARM. So there's no Intel, there's no IPv4. We said we're gonna forge ahead into the future. Did a few times, we did run into problems with that, but on a grand scheme, I think it's worth it to actually use, technologies that are modern right now and not stuff that's been there for 20 years. All right. Showed you that. Yeah, maybe a few interesting things here in the web app. We've got metrics. First time loading takes a bit. Of course, there's not much traffic here on this one that we just deployed, but you can sort of get an overview over how your application is running, what it's doing, how it's scaling up and down. We're gonna add more graphs here that tell you when it had to restart or when it added or removed the replica and all that sort of stuff. You even got metrics for your resources, so databases, caches, and all that sort of stuff. Let's see, I've got here, for instance, don't think there's much traffic, nope. So yeah, you can see the same here, and what we released, I think a week ago or 2 weeks, is alerts. So you also get alerts like your application is crashing, or you're using too much CPU, too much RAM, your disk is running full, which is helpful for the MySQL database containers, that sort of stuff. At the moment, we only sent them to Slack. Don't ask me why they implemented this notification channel first, probably because we're using it ourselves. But I think email and Telegram and all the others are gonna come soon, because Laravel has a pretty neat notification system, as you probably know, and we can just add other notification channels in the future. But that should make it easier, especially for our support, because they get a lot of questions about stuff that people can now find out for themselves and don't need to bug somebody else, and be quicker with resolving them, right? Yeah, I think, yep.
So previously you mentioned something about using Cloudflare for domains. So there's this edge case here in Greece that .gr is not supported by Cloudflare. So does that mean?
Seriously?
I think so, at least recently it wasn't.
To purchase, you mean?
Yeah. Okay. So does that mean that therefore you guys, because of that limitation, that also transfers over to you?
No, you can register your .gr wherever you want and just point it at our IP, at Cloudflare, and that's it. Or it's even in our own IP block, so you don't have to use Cloudflare at all. It just, the traffic goes through it. You can purchase your domains there. We've got enterprise customers that have their own elaborate zone setup with their own bot denial rules and firewall rules and whatever. And they just forward from their Cloudflare zone to ours, which then goes into Laravel Cloud, so it's possible. But you don't have to use it at all. No. I think there's also a plan in the future to be able to purchase domains through the Cloud Web Interface, so you don't have to bring your domain, you can just register it right there. But I don't know, if that uses Cloudflare, then you're out of luck with GR domains, it seems. It's weird, why are they refusing to support that?
No, it's like I tried setting it up and it wasn't on the acceptable.
We have a good
contact there, I'm gonna ask.
So you can handle the name, the DNS, set Cloudflare as the name server for a GR domain.
Yeah.
But you cannot buy a domain through Cloudflare.
It's a weird limitation, but yeah, they have their reasons, I guess.
Yeah, there are certain countries who have very elaborate processes to get a domain for that country, and sometimes it doesn't go through.
Yeah.
One
Interesting.
sort of stupid question, but this web interface, it's Laravel, right?
This, the web app? Yes. So the stack we're using here is Laravel with Inertia and React for the front end. It all actually runs on Vapor. So we're using another product of Laravel to run this piece of code. This then talks to our operators. in the background. And we also have a sort of admin interface for cloud where we can look at customers and what they're using, and sort of basically for support so they can better help them. And that's built in Laravel Nova, because why not? You know, we have the product, we're gonna use it to its fullest, and that's really helpful because you can jump directly from an environment in Nova to our Grafana dashboards that give you insight into the metrics, what's actually running, which also powers these graphs, but in a much more elaborate way where you can query stuff and so forth. So it's come in really handy for a lot of times.
I think there was a question behind you.
Regarding, I would like to ask you something regarding backup policy. For example, I have an application that I need. The microphone. Yes. Regarding backup policy, there is a use case that I need to have database every hour.
Yes.
Is there an easy way through your platform to restore to it?
Yes. We're doing one better. We have point-in-time recovery on all databases. So I think MySQL is not enabled in the front end yet, but it's working already. And Postgres does have it already, so you can just wait. Let me see if I can find it. I didn't build the feature, so I don't know, but I'm pretty sure if I go probably into my schema. Oh, here, backup. And then you can just say yesterday at, I don't know, 2 o'clock in the morning. And then restore that into a whole new server. Then you can copy data if you want. You can point your application at the new cluster, whatever, delete the old one. So yeah, it's really easy. And MySQL works in a similar way where I think we take one snapshot per day and then point-in-time recovery in between with just like the bin log files that MySQL has. So you can jump to any minute or second or any query you want to and have your database like that. Of course, your normal application, we don't back up because that's sort of, you know, you've got that in your Git repository or wherever. We don't really need that. We keep around the last few images so you can roll back if you deployed something you rather don't want to have. But that's about it. I think the object storage, which is R2 by Cloudflare, so S3 compatible, that we don't back up. So there you would need to do something yourself. But for the databases, yeah, we have running backups always available. Yes?
The question, how do you containerize the application? Does it have to be Docker ready before deployment?
No, you don't have to do anything. You just give us the source code of your Laravel application. But we create the container with, we sort of have, as I said, we have this base image, which is like a Docker file that has already everything that we need. And then we just copy in your source code and create the image out of that.
How do you handle configuration like that?
It depends on what configuration you want. I mean, everything in your app you can do yourself by committing into your repo if you need. Sorry?
You don't commit the configuration file?
No, the container part is completely managed by us. That's the fully managed part of Laravel Cloud. So you only have influence over what your application does. Everything else we configure on a level of, you know, what most people need, so to speak.
For instance, if I want to have several environments with different configuration for the same application, how can I achieve?
Yeah, well, again, it depends on what configuration you want. You can have different PHP and Node versions. You can have different environment variables that you put in.
Okay, for instance, I want environment for testing, for like staging, and for QA, for instance, for production. And I will have a different, like various configurations, say, for API connections or for database, things like that, for every environment.
I mean, then Yeah, you can have environment variables. So most of the stuff we inject for you, oh, no. We inject everything for you as much as we can. Let's go to this one. So if we look here, so these are all the injected environment variables. There's stuff like, you know, the host name in there and the DB. If you create one, you never have to actually read your database credentials and stuff. We just put them in here. But whatever you want to override, you know, you can just put it in here, and it even tells you, hey, that's one variable that you're overriding because it's already set in the injected variables, but you're using it, you're basically setting it to something different than we did. So that's one possibility that you can do for each environment.
I mean, okay, integration with third-party resources. For instance, I need to store API keys to connect to the external applications. So
API keys I will put into environment variables, yeah.
So, okay, and it's possible to store like various environments, sets for various deployments. So I can choose during the deployment process which exactly environment
well, yeah, kind of in the future. Right now, you create an environment, you can add all your variables in and then click deploy. You know, it's just the other way around. But I know what you mean, sort of like templated runtime environments that you choose.
Various environments like for development, for testing.
Yeah, it's coming. That's about all I can tell you right now. But yeah, we've thought extensively about how to solve these kinds of problems to make it easy for people to just, you know, never even have to interact solely to set everything up in the beginning, but then you don't have to interact with the site anymore, and you can just use your Git or Bitbucket repo or whatever and collaborate with your team there, and it'll just do the right stuff that you set up beforehand. Yes, please. Wait.
Is there a way? Yeah, thank you. So, is there a way to somehow calculate a little bit about the cost?
Yes. You don't have to calculate yourself. You can just. Oh wait. I'm not sure if my coupon is showing if I click on that now. I'm not going to click on it. But if you go to your account, your organization, there's usage where you can see all of your allowances. Like I think we've got stuff like bandwidth and web requests, which are really high. You will never hit them unless you're your project is really popular. But you also got an invoices menu tab there, which shows you all your previous invoices and the running costs for the current payment period. So you will see exactly what you got to pay. We don't have prediction yet, like AWS. We might do in the future, so we can predict on your previous usage what it might be at the end of the billing cycle. But for now, you just see what you've incurred so far and can sort of interpolate how much it will cost you.
So you say it's more like trial and error for the moment? You try
No.
some settings? And
I mean, we tell you what everything costs, and you can see how much you incur. I think it's pretty straightforward, but if you've got better ideas, please tell us. You know, I'm always up for improvements.
I was hoping for when you change the settings for hibernation or expansion or shrinking, maybe have like a rough estimate of how...
Right then and there, hey, this is gonna... Okay, yeah.
What does this affect the cost?
Yeah, I see.
By changing the settings?
Yeah, I think that's a good idea. I'm gonna bring it up with the team. Hey, we always got open positions at Laravel. Just apply. I don't think anything in design and UX at the moment, but might be. Right. Any more? Yes. Or can we? Yeah. Thank you.
Does the database has high availability?
So.
Sorry,
Laravel MySQL does not at the moment. We only roll out single server instances and not a clustered failover model. I'm pretty sure Neon says they're high available with the Postgres instances they offer us. I'd have to recheck, but I'm pretty sure. What we do offer in the future, but that's a higher price tier, that's why we didn't do it in the beginning, is just regular AWS, where you can say multi-AC failover cluster with 5 reader instances in different parts of the world, whatever. That will work, yeah.
The second question is on the backup policy. Do you have a policy with geographic location? So if you have a failover, for example, Europe, does in America have a geographic location? For example, you have 3 copies, one in Europe.
Yeah, I see. No, not at the moment. As far as I'm aware, backups are stored in the same region in an S3 bucket. But that's an interesting point because I can see the use case of saying, okay, I don't need an active standby in the US, but I'm running my application in Europe, and if that goes down, I want to be able to access it from there and start it up in another region. Yeah, good idea. I'll take both of those with me. Thanks.
The question about the scaling and out of the instances. I think it's just you just decide how many instances you want, but you don't set up like thresholds for scaling.
Yeah, right. Well, I don't know if it's actually deployed to production yet, but so yeah, the simple scaling for your compute right now is just very dumb because we just implemented one way and released it close to launch in February. What we're working on right now is actually my colleague Sylvester. He wrote an agent that's going to run alongside your PHP application and looks at stuff like how many PHP workers are running, how many messages are in the Laravel queue, you know, how much memory does each process take, how much CPU usage, and so very detailed view at Laravel and PHP itself. And we're sending all those metrics back to Grafana Cloud, where we keep all of our metrics. And we will be able to make intelligent scaling decisions in the future. So what we implemented now, which I don't think is deployed to production yet, but will be very soon, is queue scaling. So you can have your queue workers, like I showed you before. If you do a second worker instance that's just for your queue, you can have that scaled based on the amount of messages in the queue, how long they've been in the queue, and if the count of messages is basically rising or falling. And then it will intelligently decide, okay, you don't have enough queue workers right now to get rid of all the messages in your queue. I'm going to start 2 more. And once it goes down again, I can get rid of those 2 and just leave 1 worker. Of course, you can also scale on just number of items in the queue. You can say, hey, once it reaches 50, start another instance. And so I have double the amount of workers. And that will extend to our app compute. So in the future, we will have intelligent scaling on your web worker, where you say, hey, if you hit the max number of PHP processes, then we can either scale up the max number or add another replica, so your load balance between 2 instances.
How do you decide right now how you want to scale?
At the moment, it's just CPU or RAM above 60 or 70%. Very, very dumb. As I said, we just needed the feature to exist, and now we can iterate on it with a much smarter and more intelligent way. Because now we've got the metrics. We didn't have them in the beginning. Now we have the metrics. And now we can create like really elaborate ways where you can also then set the thresholds and say, hey, I wanna scale when this event occurs, and then you're gonna get more replicas.
That's why it's into the interface, so the user can set.
Back there.
So about the workers again. Let's say I have like 50 tasks that I want to run all the time, never stops. And we have like 10 workers that get the one task, finish it, and get the other from the from the list. So this means that if I have the option that you showed us with the image that is live or not, so I get, sorry, if the application is live or not. Like we set some minutes and say that if we don't have any request after 5 minutes, it means that the application stops, so you don't get charged. If I have a system like this with workers, probably this is not going to work, right?
Well, your scheduler doesn't run, and whatever your triggers, your workers won't get triggered because there's no code running while it's hibernating, right? If you've got a worker cluster that you added, I think those stay up. They don't hibernate if your main compute hibernates, but you could have your worker also running in your main app, you know, that receives web requests. There's nothing preventing you, but if that no, in that case, it would, while it sleeps, the background processes don't run either. But there's not really a way to, you know, we can't have no code running, but in case you want it running, still run it. So web requests are the only trigger at the moment that will wake up your application, and whatever is in that instance, maybe background processes, they will get started up again as well. But if you want it running all the time, you just create a separate worker cluster and you can let your main web application sleep, but still run the worker cluster if that's something you want to do.
MySQL directly, for example, rather than having the web application be in the middle of it.
Yeah, you can start a separate worker cluster and let it run there as a background process.
We can have one last question, and everything else we can discuss together.
Hello.
Right, last one.
Yeah.
Okay.
Sorry. So I have a question regarding the file system. I have an application that is usually deployed on the customer's premise, so a typical server, and sometimes on the cloud, which is a typical VPS machine. So my question is about the local server. I had tried to use cloud, but I immediately found that blocker, and right now I'm thinking that maybe in a deployment command, or in some other step, to mount an NFS directory in the Docker container and run it in, since it is in the deployment command, it will run in its container, so you will have that kind of local file system, local in the way the Laravel handles it. So, do you think this will work?
Yes, but it will fail pretty quickly, I think, because it's very brittle, you know. Also, what happens, I mean, yeah, NFS can have multi-writes, so you can have multiple replicas all connected to that. What we're experimenting with to offer more local space is actually doing kind of a similar thing, but a level deeper on the Kubernetes level, where you can say, hey, I want a persistent volume that might be connected over NFS or whatever. AWS has their own driver. And then you can mount that disk into every pod that belongs to this deployment. And that will also stay. So when all the pods are getting deleted and a new one created, it'll reconnect this persistent volume. The downside is it's slow. So it would take much longer for your application to deploy because it has to wait for this disk to be connected, which could hang, which could take minutes, you know. And it's also prone to error because even if NFS does support it, most file systems are not really meant for multiple replicas reading and writing at the same time. So yeah, what I'm suggesting is your idea might really work, you know. I mean, technically, yes, it will work, but it's gonna be brittle and it might fail pretty soon. Try it out. What I would rather do is mount an object storage bucket as a disk, you know, or just use it in Laravel. You can just, I mean, it'll just be in your environment. You can just use the S3 bucket, and if you've got big uploads, stream it to S3 and read it from there, you know. That'll always be there. So it's probably a better idea in the cloud native mindset to use it that way than to hack together a local storage. That's
need rewriting some parts of the app to handle the S3.
Laravel supports S3 just as it is, just don't use local use. I think default is what's getting injected if you add one here. Works the same. All right, I think that's it. Thanks everybody. I'll still, thank you. I'll stick around drinking Coke Zero, so ask me whatever questions you still have. Thanks.
Perfect. Thanks so much for this talk. So that's not all for now. Talks are done, but we're not done yet. We have food ready for you and some surprises as well. So thanks each and everybody of you for coming here today. Thank you so much. Big thanks to our sponsors that flew all over from Austria and Kavala as well. So a big round of applause for them. Thank you so much. And of course, I would also like to thank Hack the Box they gave us and they lent us their beautiful space in order for us to host this event here. So thank you, Hack the Box. Another round of applause. Yes, let's do it.
I can't even get everyone. It's too many. Thank you.
Thank you, guys. So we'll see you around.